Kirchhoff laws, right? That which proves simply law of conservation of energy. Law of conservation of energy. So what the law of conservation of energy says? Energy neither created nor destroyed. So here it is simply modified. Law of conservation of charge. Right? Law of conservation of charge. Here, according to this law, charge neither created nor destroyed. So this is law of conservation of charge. Charge neither created nor destroyed. Right? So here, simply what happens, the charge is transferred. Charge is transferred. So here, simply, have you observed that household connections, actually, you are receiving the current from electric poles into your house, right? Into your house, simply, you are receiving that energy from the electric poles, right? So here simply you are hanging wire on the two wires of electric pole, right? Then it is just given connection into your electric meter, right? So into the meter you are taking the connection. Then from there into room, right? Or into the hall, into the kitchen, right? Into bathrooms, into corridor, outside, right? So everywhere you are giving connections into the electric boards. So here, from one wire, you are giving many connections, right? One wire, you are giving many connections. The wire is connected between the pole and the electric meter here, right? From the meter, you are giving the connections into many electric appliances connection, right? So here, simply from one point, you are dividing that, right? From one point, you are dividing into many, right? So that which is connecting many together at a point, right? That which is connecting many together at a point. What they are connecting actually? Wires, right? Wires. So many wires are connected commonly at one point. So that point where you are dividing that into many circuits, that point is called here simply junction. That point is what? Simply called a junction. So here at the junction, what happens? So here from the electric wire, you are receiving the electric current. You are receiving electric current. So here what amount of current? Simply certain amount of current will be received, right? According to your need. So it is fixed amount only, right? The fixed amount of current allowed through your main wire, main supply. Then from that supply, you are receiving that energy into household circuits, right? So that is divided into many circuits, right? So here, what amount you are getting from the junction, that you need to verify. So for that, you are able to make a simple circuit also. It is possible. Use just a 9-volt battery or 12-volt battery, whatever it may be, right? So here, the battery is electric source for you, right? The battery is electric source for you. Then from there, just you have to make a path, right? So using ammeter here, right? So it can measure the current what you are giving from the battery, right? So make a junction like points, right? So from there, you need to connect many circuits, right? Many circuits or many appliances here, right? One is a DC motor, one is a LED bulb, one is any other torchlight bulb, right? Like that. So here, in each individual circuit, you can fix a ammeter. If one only available, just you need to verify by connecting it in series combination. Use many times, right? So here you will get a current, what amount you are receiving here, right? What amount you are receiving from the battery. Then individually you are connected this ammeters. So what amount of current is allowed through this circuit? What amount of current is allowed through this? What amount of current is allowed through this? You are getting. Suppose here, let me take this current as I. This is I1. This is I2. This is I3. So what about this point? What about this point? Many wires are connected only at a one point. So this is what junction. This is what junction. So at the junction, you are receiving one current and you are sending many currents, dividing that into many parts, right? So here, always that leaving current, suppose I1, it is smaller than the receiving, smaller than the receiving. I2 is smaller than receiving current. I3 also smaller than receiving current. Then, how do you justify? Here, what amount of current you are sending from the junction? What amount of current you are sending from the junction? So what amount I1 sending, I2 sending, and I3 sending? The total you need to get sum of the currents you are sending. That simply we are saying as leaving the junction. This sum is what? Leaving the junction. So here, this amount you got as something. It may be 20, 30, 40, or 10, 5, 1, whatever it may. It's a sum, right? Then you have to verify this sum is equal to the amount you are receiving or not. So here I am asking you to compare the sum of the currents, right? Sum of currents leaving, right? Sum of the currents leaving is equal to the sum of the current you are giving to the junction, right? So only I am given only one current to reach the junction. I am given only one current to reach the junction. So that I is equal to sum of the currents I1 plus I2 plus I3 or not. That you have to verify. So finally, what you are verifying, your justification is I is equal to I1 plus I2 plus I3. Right? So what you are going to notice here, I is equals to I1 plus I2 plus I3. So what I am able to say here, simply the sum of the currents reaching here, sum of the currents reaching here, right? What here? Junction. Sum of the currents reaching junction. Only one is there. If one more is added, that also we can take it into account, right? Will be equal to sum of currents leaving junction, right? This is Kirchhoff's law, given as first law using a junction. So this is also called as junction law. Also called as only it is observed currents. So currents law, law of currents, law of currents. So what Kirchhoff's made here, he observed the relation between the currents at the junction. Observe the relation between the currents at the junction. So how many currents are reaching the junction? How many currents are leaving the junction? There is no importance to them. but the importance is given to the currents sum. What amount reaching the junction here and what amount leaving the junction. So the sum of the currents reaching the junction will be equal to sum of the currents leaving the junction. So this is given by Kirchhoff. So that's why this law is said to be Kirchhoff's law of junction. Kirchhoff's law of junction, also named as Kirchhoff's law of currents, or also called as Kirchhoff's first law. Are you clear about this one? What you need to understand here, some of the currents leaving the junction and some of the currents reaching the junction always same, always same. So here simply this is Kirchhoff's first law. So it is based on the law of conservation of charges. Law of conservation of charges. So why I am saying charge here? Because current is the amount of charge flowing through the cross section in a unit time. So that's why it is said to be law of conservation of charge. Law of conservation of charge. So it is satisfying the law of conservation of charge. According to this law of conservation of the charge, at the junction, whatever it may be, the amount of charge is reached, that same amount of charge will be sent from the junction in different paths. As many you connected here, right? So some of the currents reaching the junction and some of the currents leaving the junction always equal. Suppose here I am taking the currents reaching the junction, amount I is something I1 and I2. Then the currents leaving the junction unknown, I2, I3, I4, I5 and I6. Then what you can write the relation here? I1 plus I2. Only these two are reaching the junction. And what amount leaving the junction? The amount of currents are reaching and leaving is here. I1 and I2 are reaching. I3, I4, I5 and I6 currents are leaving. So its sum is equal to the sum of the currents reaching. So this is the equation I am able to write according to law of junction. Right? It's a law of currents or law of first law. Junction law, loop, first law, and Kirchhoff's law of currents. So anything you can use the name, but the law says here sum of currents reaching and leaving same. Simple. Reaching and leaving same. What currents? So here, especially if you talk about this point, nothing is using, not utilized any amount of charge by the junction. Right? So it is receiving and giving back. The amount receiving and giving same. So neither created nor destroyed, neither used, right, nor destroyed. So that is called the law of junction. Are you clear about this one? Give me your quick response. Have you got idea about Kirchhoff's first law? So this is first law. So according to this, neither created nor destroyed. So charge completely same amount of charge receiving and the same amount of charge sending from the junction in different paths. That means in different circuits. Right? So this is about Kirchhoff's law of currents. So based on this, you are able to solve the problems. You are able to solve the problems. For example, I am taking a junction, right? I am taking a junction here. Towards the junction, the amount of currents are reached. I is followed here. Suppose 5 amperes current reached by the first wire and 6 amperes of current is received by the second wire at the junction. Then here the leaving the junction are here I am taking these three wires. Right? The amount of current allowed through the first wire leaving the junction is taken as something unknown value I, and the amount of current sending or passing through the second wire leaving the junction is given as 4 amperes, and the amount of current passing through this wire which is leaving the junction is taken as something 4 amperes. Then what about the amount of current passing through the first wire leaving the junction? Can you calculate this one? What is I value here? What is I value here? So according to law of junction, here law of currents, sum of the currents reaching here 6 plus 5 is equal to sum of the currents leaving junction. So unknown value is there. So here I am taking the sum of these two and transposing opposite side. So what will be written here? I is equals to 6 plus 5 is 11 and 4 plus 4 is 8. So here plus 8 becomes minus 8. 11 minus 8 equal to 3. So 3 amperes of current is allowed through the wire leaving the junction with current I is equal to 3 amperes. Have you got idea? Have you got idea? How to solve this one? Is it clear? So based on the junction law, this is the simple problem will be created like this. Okay. Then somewhat depth. So here it is like this. So no circuit is given. Just the diagram is given like this using the resistors and given point something A, B, C, T. And the potential difference are given at the point A is suppose 70 volts and D unknown voltage, and at B 10 volts and at C 0 volts. Right? Then what about the potential difference at D is equal to what? Right? And the resistance values are given here. I is followed. Suppose it is taken as 10, 20, and 30 ohms. Can you calculate this voltage by using the law of junction? So where is the junction actually? Can anybody answer? Where the junction is there? What is junction? What is junction? Just think about it. Just think about this. The junction is at point D here. The junction is at point D. Why only D acting like a junction here? Because many wires are connected here. At least 3. So 3 there at a common point D. So D is what for us? D is junction. And do you know the currents allowed through the individual branches like AD, DB, and DC? Don't know. So I am assuming I1, I2, and I3. So what about the junction law says? Sum of the currents reaching the junction will be equal to sum of the currents leaving the junction. Right? Sum of the currents are reaching the junction will be equal to sum of the currents leaving the junction. Right? So here, just help me in writing the equation. Right? Rohit, tell me which currents are reaching the junction here. Rohit, are you there? Yes. Okay. Sricharan, which are reaching here?
I1.
I1 is reaching. Okay. What about I2, I3?
Leaving the junction.
So what the junction law says here? How to satisfy that by my equation? What do I write?
I1 is equals to I2 plus I3.
Okay. So here I1 is reaching the junction, I2 leaving the junction, I3 also leaving the junction. So the equation is written like this. But using this, how do I find V value? So I don't know V here in this equation. So convert this I into V, because here voltage is given and the resistance is given. So here I V R relation. I V R relation. So what their relation here? V is equals to IR. Then from this I is equals to what? V by R. So I1 equal to V1 by R1. I2 is equal to V2 by R2. I3 equal to V3 by R3. Then replace them in your equation. I1 V1 by R1. I2 V2 by R2. I3 V3 by R3. Then potential difference V equal to, we know already. What is the difference between the ends? The difference between the ends. So here I know current is flowing through a conductor from high potential to low potential. So where you can expect high potential, at A or at D in the branch AD. Predict here. At A you have high potential, or at D you have high potential. Can anybody? Where you have high potential? Where is high potential? Answer me. Rajita, where is high potential? Unable to answer? Current direction is given always from high potential to low potential. So in the branch AD, I have current direction from A to D. So high potential is expected at A and low potential is expected at D. So here V equal to high potential minus low potential. So the potential difference V1 equal to will be taken as VA minus VB, high potential to low potential. Then what about V2 is equals to V2 equal to VD minus VB. Then V3 equal to VD minus VC. Are you clear about this? Go to quick reaction if it is clear how I am written this. Only two are saying clear. So high potential to low potential, that energy gap is there between the ends. That energy gap is taken as difference, nothing. So A at higher energy, B at lower energy, always higher energy to the lower energy, right? Higher energy to the lower energy, the charge is moving. So that I followed. So VA minus VD is taken for V1. So that I am replacing in the equation. That I am replacing in the equation. So here just I am going to clear this something. I changed this one. I followed here V1 by R1. So what I am writing here, V1 is equals to, I am writing V1 is equal to VA minus VD by R1 is equals to 10 ohms given in your circuit. Then V2 is equal to VT minus VB is given by resistance is given in that branch is 20 plus VT minus VC by the resistance is given as 30. This is the relation we are changed is like this. I1 equal to I2 plus I3 written as VA minus VD by 10 equal to VD minus VB by 20, VD minus VC by 30. Then just solving this one. So I'm changing this, just erasing what I am not required here. Okay. Then now here VA is given as 70 and VD is given as unknown, VD only by 10. So here just before that I am able to cancel here all the zeros, common and cancel. What is left? By 1. What is left? By 1 is equal to VD minus VB. So VD I don't know, VB I know, that is 10 by 20 plus, 20, need not to write 0 here, 0 already cancelled. Then VD I don't know, VD minus VC is 0 by 3. So now LCM is 6. LCM is 6. So what I will get here? 3 VD minus 30 plus 2 VD minus 0 means 0 only. Then here 70 minus VD remains at LHS side. This you have, right? Now what to do? Just solving. How to solve this one? Just taking the cross product of denominators, opposite sides, right? So here simply this 6 is transferred to opposite side. So it will become multiplier. So left side that will give you 6 7 times 420 minus 6 VD is equal to right side 3 VD 2 VD. It will be 5 VD minus 30 minus 30, right? So this I got. Then VD terms one side. So here 5 VD, another side 6 VD. So totally 11 VD. So this one taken towards right side. Then this 30 opposite side. So what I will get? 420 plus 30, 450 it will be. Then VD equal to what? 450 by 11. So this amount you have here 40 points. What will be here? 8 times something. 88, 99, sorry. 40.9 volts. Have you got idea? How we solved? So I got the potential difference at a point D is 40.9 volts is the answer. So this is about junction law and its applications. Are you clear about this one? Or there is any confusion? How we solved? Just the junction law is changed as this voltage and resistance relation using Ohm's law. I equal to V by R. Ohm's law, V equal to IR by transposing I is equals to V by R written. Clear? Just go to quick reaction. If there is any doubt, raise your hand. If there is any doubt, raise your hand. Right. So if you are in confusion, just follow this again. Right. So join immediately using the same link.